Hey, welcome to Engineers Workshop. Well, as you can tell, I'm not in the shop today. I'm actually on the road doing a job for work in Portland, Oregon. So obviously no machining, but what I do have for you is a chance to geek out with me on a trip that I made to Pittsburgh a while back to visit my daughter. And she took me to the Duquesne Incline. Now, an incline is it's a railway that is steep enough that the trains cannot power themselves up the hill. And so it's basically an engine house at the top and two cars on the cable. They counterbalance each other. One goes up while one goes down. And I got to get into the machinery room and see the workings of this working incline in Pittsburgh, PA. So check that out. I hope you enjoy it. Also, I have some nice shots for some really quality vehicles at the Frick Carriage House, which is also in Pittsburgh. So enjoy this little trip up and down the Duquesne Incline and see some classic vehicles at the Frick Carriage House. Thanks.
Oh yeah.
Yeah. Oh, that's okay.
This is the Duquesne Incline, is that what it's called?
Yeah.
And it's from the late 1800s.
If you get stuck on it, you gotta walk down the creepy ladder on the middle.
Oh, that's what that's for.
Yeah.
That would suck.
Yeah.
Neat cars. Original cars.
They were going to shut the whole thing down in the 1970s, I think.
Uh-huh.
And then there was a big push to save the incline, and I think now it's managed by like a non-profit group.
That's cool.
Do they give you a warning when they start?
They do come and close the door.
Yeah.
Okay. There we go.
In the morning when you got like it was packed and you couldn't get on it, then you just be like, oh, I guess I get to the next one.
That's
Pretty
how it
neat.
runs. I'm absolutely sure. You almost saw the city.
Then it's like if you're they want you to sue it on Iowa.
Oh,
Yeah.
yeah. That's how it is. How it works. No, this is fine.
It's not the smoothest ride.
It's almost over.
Some very light rail.
A wooden roller coaster.
Yeah.
Look out.
40-pound rail.
It's a weird gauge spacing too.
Yeah, I don't think it's standard gauge. Looks like 5 feet or 6
I think
feet.
it's like 5 feet. It's the standard for Mongolia.
Really?
Yeah. I think it was more just when they built it, they didn't really have rail standards.
They keep their cables well greased.
This is what Karina was saying. They must
Like this?
drench it on either
Now
end.
we're coming into the station.
Well, it's a good thing they do, because most cables have a fiber core, and the fiber core can absorb moisture, and then the cable rusts from the inside out. You don't know it until it just breaks one day.
Oh, that's terrifying.
I think the view is better for this one.
Contacts, what are those contacts? Must be what stops
It
it.
is. Isn't it cool? Yeah. Was that fun? It was.
If you've ever been to Pittsburgh, you'll notice that it's very hilly. I think it would challenge San Francisco as one of the hilliest cities in the country. And there are people that live on the top, and there are industry, usually at the river level, on the bottom. So it became important in the mid-1800s to have a better way to get people and equipment and fuel from either the top to the bottom or vice versa. Pittsburgh had quite a number of inclines, and the Duquesne Incline was not the first one. Some of the inclines were shallow enough pitch that the cars, whether they're either passenger cars or freight cars, did not have the built-in tilt to them to keep the floors level. They just simply put conventional train cars, whether it's passenger or freight, on the rails and let people sit at an angle. Some of the freight inclines were truly massive. The gauge or distance between the rails were as big as 10 or 12 feet, where a standard railway car gauge is 4 feet 8.5 inches. And if you look at this car, you can see from the scale of the two gentlemen standing there that this could haul a lot of either equipment, or in this case had a small passenger compartment tucked inside the actual open air cab. The Penn Incline, which was done in 1897, was designed primarily to carry coal. So what they would do is they had a 30-ton incline car that would carry a 10-ton freight car with 20 tons of coal in it. So going up, you'd have a 30-ton car that would be counterbalanced by a 10-ton empty car. So this thing had a differential load on the cable of 20 tons. The design load of the cables were 300 tons when new, and best I can tell, that's like a 3-inch diameter wire rope, and they were used until they lost half their strength, where they were down to 150 tons, and then they were replaced. It was 840 feet long, and the track rose 335 feet and had a 232-foot span over the Pennsylvania Railroad tracks. Necessity being the mother of invention, it wasn't long before some inclines were designed that would actually make curves from top to bottom, as in the case of the Knoxville Incline, which was a combination freight passenger line, or the Castle Shannon No. 2, which had vertical changes in grade, and that one used the train cars that were basically just parallel to their wheels, and the pitch of the car moved up and down with the rails. In each case, guide rollers would help the cables make the transition either vertically or horizontally around the curve. I believe there is only one of those combination freight passenger inclines still in operation. That's the Johnstown Incline, which is located about 70 miles east of the Duquesne Incline in Pittsburgh, and it is in Johnstown, PA. And it has an open cargo area car with a gate, and then a small enclosed passenger area with a bench that rides inside the car going up the slope. One of the unique aspects of the Duquesne Incline is because of its location. It is just east of 376. If you exit 376 before it goes into the tunnel, it basically puts you right at the base of the incline. And at the top of the incline, the engine house is located on the side of Grandview Avenue. And so they didn't have room to have the equipment continue in a straight line, and it would be basically across the street. So what they did was they put a right angle turn in the cables, and the cable drum and all the machinery is located at a 90-degree angle to the incline itself. And I think it's the only one that is like that, and it's the one that we rode that's still operating today. There's actually two sets of cables attached to the cars in the Duquesne Incline. The first cable is the safety cable, and the safety cable runs from the car to the top sheave, and from the top sheave to this is basically a take-up mechanism that goes back and forth to the next sheave and then down to the other car. The reason they have a take-up mechanism is because of the temperature changes that you have to allow for in the cable. Over the length of the course, which is fixed, the cable can lengthen and shorten by about a foot over 100, let's say 100 degrees of operating, from 0 degrees to 100 degrees. And what had happened is the car at the top would be positioned exactly right, but the car at the bottom would not. And so they have to be able to shift this take-up mechanism up and down in order to make sure that the top car and the bottom car are hitting their platforms exactly right. The second cable, which is the actual drive cable, goes from the car to the shiv, down to another shiv, over to the big drum, round and round the big drum, back over this shiv, and down to the other car. It also has a take-up mechanism, but this cable is a lot longer, I believe, because of the additional turns that the cable makes. And I think that take-up mechanism is down in the right angle wheel here. So that's how they keep everything connected. Safety cable connecting the two cars, drive cable also connecting the two cars, but going around the mechanism to power the cars up and down.
Window.
Oh yeah.
That's the one that I said, did you see those? And you were like, yeah, yeah.
No, I did not.
So, where is the main...
16.
That is cool. So, how many feet would you say that's about 12-foot diameter cable drum? And the teeth on this gear are individually replaceable. Look at all the wooden wedges driven in. I think the teeth are now, they look like they're polymer. I bet you originals were wood.
What's the purpose of all the wedges underneath that?
That's holding them in,
Oh.
jamming them up so you can replace the teeth without having to replace the wheel.
But wouldn't every tooth need a wedge then?
Probably does have one. It's just they're not
No.
they're not
Not all.
all sticking out.
Cable wraps around 20
Little bit of whip, 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 and cable.
Incline was built in 1877 and cost $47,000. Then
Costs how much?
$47,000 in 1877.
Won't start. The buttons don't start the video.
That's annoying. Like a low battery thing, or just?
Look at the thing in the plexiglass case. That is a circuit. It's got a traveling contact on a lead screw, and it moves from one end to the other. It's all calculated out so that it knows when the cars are nearing the top of their travel. This device in the plexiglass box.
Oh, that's what I was just trying to read about.
Oh yeah, this was a door, now it's a...
Also, beautiful day. It was god-awful hot when Mom was here.
This is so nice.
I like that code wiring there is with wire nuts hanging out above the wheel.
Water is.
It looks so strange with it up at that angle, but it's level. The incline doesn't look as steep as it is. I knew I was right about the wooden teeth. 30 years an engineer taught me one thing, that nylon or PVC was not available in 1877. The quality of the wood would probably be hard to equal in today's lumber climate, so good substitution to go to the polymer. So they have 130 pairs of teeth that are held in with wooden wedges driven in on the underside of the rim of the wheel. This is a cross-section of the incline showing the terrain underneath it. It looks like it's pretty far off the ground in a couple of places. And this is the end of the take-up mechanism. It shows the adjustment. It just moves those shivs back and forth to lengthen the effective length of the cable between the cars. From the ground looking up the hill, you can see that it's just mostly woods in between. And to look across the where the three rivers come together from the lower station. And then the view from the top, of course, beautiful point. And you can see the one river is kind of muddy and one river is pretty clean. The bridges in the background, pretty impressive. I could see the contractor saying, yeah, I need a bridge that's, X feet long. Give me a price for 3 of them. I'll take 3 identical ones.
This was like one of those speeding car drives that just drop you.
It's deceptive what the midpoint is of the incline.
Yeah, I don't know if I could really accurately guess it.
Especially since you can't see above you.
Because it looks like we're most of the way down and we're not even near the halfway point.
Oh, look, you can see the doors down there too.
Oh, yeah.
That must have been how they loaded baggage at the other end.
We had a little bit of time to poke around underneath the base of the incline and get a few shots of the underside and the structure that supports it. And lo and behold, there was a bunch of blackberry. We thought it was blackberry bushes, but it was actually black raspberry bushes. So we picked a few handfuls of black raspberries to eat. Another thing that Pittsburgh had a lot of besides inclines was money. So we mentioned before that, if you're a Frick or a Vanderbilt, you pretty much had one of your mansions in Pittsburgh. But if you're August Fronheim, who was into pumps and hydraulics, you might have a mansion like this one. Or, of course, if you did ketchup and pickles like the Heinz family, you lived in this house. Or if you remember the King family, you would have this mansion. No comment about the shrubbery design there in the lower right. And of course, George Mellon, who was a steel baron, had this nice little house on the hill, which featured an indoor swimming pool. Brennan, you're not supposed to get into the museum exhibits.
It says right there, picture yourself behind the wheel.
Picture yourself, yeah, picture yourself. It doesn't say get behind the wheel. This is a 1909 Stanley Steamer Model R Roadster, and it is absolutely gorgeous. Look at the 6 or 7 chime whistle. And this is a bulb horn. Autometer. I don't know what the geared device, probably a speedometer. Coming from the front wheel. Interesting feature of the Stanley Steamer is the single rear seat. I hope you enjoyed that little opportunity to geek out on a incline railway in Pittsburgh, the Duquesne Incline, and a chance to see some really nice vehicles at the Frick Carriage House, also in Pittsburgh. Be on vacation next week, so no video again, but we'll be back with some machining content in mid-August. I've got the projects stacking up on the Spitfire and trying to get that new tool post installed on the Acroturn lathe, so plenty to do. Until then, thanks again for watching from Engineers Workshop, and as always, stay safe.